So another special case about present worth method is called capitalized worth method. Okay, this is not a new method. It is just an extension of the present worth method, just like the bond issue. Okay, it's a special case. So what is the capitalized worth method? You can imagine in some cases, the realization of your revenue or the benefit from a project could be very, very long. Cases could be building a road, building a bridge, building a tunnel. Okay, so those civil structures, they're gonna stay there for a long time. You're not gonna build a bridge temporarily and then you take it off. Usually you won't do that. Okay, and you of course you don't like build a road and then build a highway and then after 1 year you take it off. That's very uncommon. So usually the civil infrastructures, they are gonna stay there for generations and generations. So sometimes you can even say that the benefits from them are coming year by year until that infrastructure is retired. And of course, every 10 or 20 years, the Department of Transportation is going to maintain those key infrastructures so that their lifespan can be seen as infinite. Because we want the service for us, for our next generation, and for generations to come. Okay, so that is why we want to use the capitalized worth method, because the timeline for that project is going to be infinite. So now let's take a look at this definition. In some instances, revenues and expenses are not realized over a finite number of periods, but over an infinitely long period. You can see it as an number of interest periods goes to be an infinite number. The capitalized worth method can be applied in these cases and is a special case of the present worth method. Why it is a present worth method? Because if we are looking at an infinite timeline like this, okay, it's infinite, so I don't know where is the end of the timeline. And at the beginning, you might invest some amount to build a bridge, right? And then every year, you have that bridge serving the traffic, serving that community, okay? And those services will, generate economic impact, which can be calculated as some receiving, okay, in the society. So every year, you're gonna have some revenues, and also of course you have costs to maintain that bridge, but the net benefit is gonna be some cash flow income. Okay, so the arrows, they are annuities. Okay, and they are telling you that every year your bridge is benefiting the community in some specific amount of dollars. Okay, and it happens every year. Until generations after generations. So we can say this type of problem is a infinite time project problem, and still we wanna evaluate if this type of bridge is a better choice compared to the other type of civil infrastructure in investment. Okay, you still want to see if you want to accept it or not. So the way you do that is still you want to convert everything back to the present time. Okay, so for this for this amount investment, it's already at present, so we don't have to convert anything about that. But another part, like this annuity, you want to convert that back to the present time. But if you go to check the interest tables in Appendix C in your textbook, you will see that the very last row of that table is going to be n equals to 100. Okay, so what do you do if the n is going to be infinite? What factor do you use? Well, you don't really have that factor. So we need to use this method called capitalized worth method. It is very easy to use. It's first thing is that you need to know it's used to convert the annuities on the infinite timeline back to the present. Okay, so it's only for converting the annuities. Okay, so because of course if you are converting the annuities, then you're gonna use this equation, right? So a times p slash a I percent, usually the infinite symbol will be n, right? That means your timeline is finite. But if it is an infinite time, then we have some mathematical equations going on, and you don't have to worry about the internal calculation, but somehow it is proved that this equals to this very simple equation. So it means if you can determine that the timeline is going to be infinite and you want to convert all the cash flows, the annuities along that infinite timeline back to the present, you can just use the A, that annuity, over the interest rate. Okay, so that is the capitalized worth method. Okay, that is very easy equation to use, but you just need to know when are you going to use it. Okay. And because this is to help converting the annuities back to the present, so actually this is just one type of PW method. All right, now let's take a look at the real case. Okay, so for example, a project which pays you 1,000 per year. So 1,000 per year, that's you're receiving every year the same amount, so it is annuity at an interest rate of 4%. Okay, so now let's take a look. If we say the timeline is 10 years or 20 years and 50 years and even longer, 100 years, and then if we say it's 1,000 years, 1,000 years compared to 10 years, we could say that's something infinite. Okay, so let's take a look at the values of these annuities. When we convert them back to the present time, what happened? What kind of values of the PW we can have? Okay, and how do we use that simplified capitalized worth method to calculate the very last item? Okay, so if we say, so first of all, let's just draw the diagram. Okay, so if it's 10 years, the diagram is gonna be 0, 1, 2, 3, and then 10, right? And then we know that every year you're going to receive 1,000 for that project. So it is the annuity at the end of every year, and A is 1,000. And we know the I is 4%. Okay, so right now our task is to convert these annuities back to the present time, and then sum that with some investment at the present time, and then that's going to be your total PW. But at this point, we only focus on the PW from the A, okay? Because you don't have to convert anything that already happened at present. Okay, so now how do you calculate the PW from, excuse me, the PW from A? How do you calculate that? It is to find P given A. So the equation is going to be A times P slash A, 4%, number of N, now it's 10, right? And if you calculate this, you're going to get the value of 81110.9. Okay, so that is the present worth of these annuities occurring at the end of every year for 10 years. Now let's do the second case. Say if it's 20 years, okay? So first we still draw this timeline. And 0, 1, 2, 3. But we end it at 20. Okay, so again, every year you still have that 1,000 as you are receiving, net receiving, okay? I is still 4%. So for this case, the PW from these annuities is gonna be still A times P slash A, 4%, but now the number of years is going to be 20. And then the final result is 13,590.3. Okay, now let's do the third case. So we have more years, 50 years. But still, you can use the interest table in Appendix C. Okay, so almost the same, just with a longer time period. A is 1,000, I is 4%. So now the PW from these annuities is gonna be A times P slash A, 4% and 50. And now it is 21,482.2. Okay, now let's say if we have 100 years. Okay, so we end up at 100. Wait a minute, it's 99. Okay, so every year you still have these annuities. Okay, and your I is 4%. So the PW from these annuities for 100 years is going to be A times P slash A, 4% and 50. And 100. Luckily, in the interest table, you have your last row giving you the factor value for n equals to 100. Okay, and if you use that value, you're going to have 24,505.0. Okay, then what is the value for infinite number of years? Okay, for example, like 1,000 years, 2,000 years, what will happen? Okay, so before we answer that, we know that we're going to use the capitalized worth method. Okay, that's going to be PW is going to be from A is what we call the CW, capitalized worth, and it's gonna be A over I, okay? And then the A is 1,000, I is 4%, so that answer is gonna be 25,000. We know we're gonna use this, but now let's just illustrate all of these values on a chart so you can have an idea like why we say if it's infinite years it's going to be just this simple equation without any factor method. So now let's try to draw the values on the chart. Okay, so let's see. We need a space to draw it. Let's just draw it here, maybe here. Okay, so let's say our y-axis is the PW from A, or we can say that's the CW, okay? And the x-axis is gonna be very long, that's gonna be years. Okay, so we start with 10, 20, 50, 100. Maybe we have 200 and we don't know. Okay, so when it goes to the right side, it's infinite. So what we have for the PW for every different number of years. So when number n is 10, we know it's 8,000 something. So let's say here is 10K. And then it's 15K. And then 20K. And then 25K. Okay? See, that's the values on this y-axis. So when time is 10 years, we know it's 8,000 something. So the dot is gonna be here. When it's 20 years, it's 13,000 something. So we know it's lower than 15. When it's 50 years, it's 21,000. So 50 years, it's over 20K. And when it's 100 years, it's 24,000 something. So we know it's getting closer to 25. Now let's just draw the line of 25 on this so that we can see it clearly. So 24,000 something should be very close to that line. Okay, and so if you can calculate when it's 200, I can tell you it's gonna be even more closer to this line of 25K. So if you connect these dots, you're gonna have a curve opening to the bottom and getting closer and closer and closer to this dotted line, which gives you the 25K as your present worth value. But before the number of years get to the real infinite, this curve is going to be just getting closer and closer to this dotted line. Okay, it never gets to the dotted line until it gets to the infinite number of years. So that makes sense. So which means the infinite time, your present worth is gonna be 25,000, and that's the maximum. So every number of years, it's just getting closer. Getting closer and closer to that maximum ceiling, but never touches it. Okay, and then so this is just a visualization to tell you that for infinite number of years, we can just use the simplified equation to give you a number for present worth, and that present worth will be the ceiling. So until you get to the infinite years, the values of present worth is going to just get closer and closer to it.